many are joining us for the first time tonight? Okay, very good. Glad to have you with us. A little bit about the group. Meetings are free of charge and open to the public. We discuss anything and everything related to .NET. We'd like to give a big thank you to our sponsors, Tech Systems for sponsoring the space, Inedo for sponsoring the after-meeting prizes, as well as pizza and drinks, and NIS Technologies for the video recordings that will be posted on YouTube later. Typically, the meetings go for about an hour and a half to 2 hours, and then afterwards, the second portion of the meeting, or the networking portion, takes place over at Simon's. So, strongly encourage you all to come out, join us for a drink, network with others, find out who's working where, what they're working on, and maybe even ask our speaker some additional questions. So, for tonight's presentation, Hasan Savran from Progressive Insurance is going to be presenting on new features in SQL Server 2017 and 2019. Hasan has been a developer for 20 years, I believe. Is that right? Recently at MVP, and he's been tearing up the speaking circuit all over the place. You can find him on Twitter and LinkedIn, as well as a variety of different cities and states every weekend presenting something SQL Server related.
That's right.
Been doing a great job of it so far.
Thank you.
So, without further ado, just a couple more announcements actually. Restrooms, if needed, are straight down the hall on the right-hand side. And lastly, please put your cell phones on mute. So, once again, without further ado, turn it over to Hasan.
Thank you. Thank you for coming to my session today. I'm going to speak about the SQL Server new features, and I'm going to focus on the developers here. I have some for 2017, 2016, and 2019. But before I start, let's actually see who 2016. Anybody's playing or waiting for 19 or excited about 19? Okay, cool. Let me talk about myself first before I start. My name is Hasan Savran, and I just became Microsoft MVP in April. And I'm a business intelligence architect at Progressive. And my team is responsible for daily analytics of the claims and reps. And we use mostly SQL Server for our data. We use MVC.NET for our web applications, and we try to use as much as we can the SVG graphs in our web application to give the custom reports to our users. You can actually, if you are looking for any opportunities, we are hiring, and please check our website here for the whole Progressive. If you are looking for a job, you can just ask me, because we are looking for 2 people who is interested for business intelligence, who knows SSIS and SSRS. If you are interested, please let me know, because we are looking for it in junior level and senior level. So please let me know maybe after this session. You can follow me on Twitter, and I'm in LinkedIn too. I'm pretty active out there. I share all kind of information, and I have a blog. And please follow me. So this is going to be our agenda today. Since this is not just like 1 hour session, I can maybe try to actually go a little bit more than this today. So we are going to look at the Linux support, which came with the 2017 version. We are going to actually look at the graph database tables. It was pretty popular, and people kind of stopped talking about them. Why? I don't know why, but I'm still talking about it. And we will see some of the query processing engine updates, which I know developers not really care about that much, but I would like to actually introduce you that part, because that's the part that mostly DBAs and developers fight for. So I will try to kind of introduce you the query processor engine. And I will show you the machine learning. I will show you how to run R in SQL Server, R scripts. And I will introduce you the in-memory tables of SQL Server. We will look at the temporal tables and some of the new functions of 2017. First, I'm going to start with the Linux. So Linux became available in 2017. And if you want to install the Linux directly to, SQL Server to Linux directly, you are going to need one of those operation systems. And you are going to need at least one of those versions for each of them. If you don't have any of them, and if you have another operating system, you can actually get the container from the Docker, and that one is actually a Red Hat version, and it will work in any operation systems of Linux. I'm not going to go into Linux how to install it or to the details, because before even you go into installing the Linux, you kind of need to check out what is available in the Linux version. It is not the same SQL Server, unfortunately. It does not have all the features and all the services. So if you are thinking about actually moving to Linux, you want to actually ask yourself or your customers or your manager if you can survive without any of those services for the future before you. For example, this list here is for the 2017 version. As a developer, I am fine because all the core database engine is already there. So all the JSON functions, all the in-memory tables, everything is there. So you are fine. But your customers might have issues. For example, services, right? My customers are not going to survive without that. My manager is going to ask me the analytics services. That's most of the time I do that. And we have some kind of idea right now, since the 2019 is coming up, what is going to be available. So for now, we know those three options is going to be available in 2019. So you can run machine learning in 2019. Linux version, replication support is going to be there, and Polybase is going to be there. But still, we have some really big services here it's going to miss. Some of them might be challenged for Microsoft to actually move to Linux. For example, the file tables here, right? File tables are generated in Windows file system. In Linux, you might have multiple files. And I don't know how they can actually support that. Maybe it's easy, I don't know. But still, we are missing those in 2019. So if you are thinking about moving to Linux, you should really pay attention to this list and go from there. The best part I like about the Linux version, it's very easy to install it. There's not that much next button out there like the Windows version. A couple of commands and you actually have the SQL Server running, so which is great. Next one I'm going to cover is the graph database tables. I picked this picture because actually I think this picture is representing the relational database tables, right? So if you are going on this highway here and you want to join here, you cannot just jump here, right? If you're with the car, you have to actually take the curves, maybe 2-3 curves to be able to actually go here. Graph database tables is giving us actually a different kind of solution for this problem. In these days, like everything is connected, right? And everything is connected and everything is changing very quickly at the same time, including your business processes. When your business process changes, usually your data changes. In relational database tables, when your data schema changes, the relational database doesn't really like it. Or it's not easy to create tables or relations without breaking what you have. It might get slower because joins usually means more joins means slow queries. So it's not really easy to change things. Also, in relational database tables, you cannot create many-to-many relations between two tables without creating a whole new table, which is they call junction tables. So graph database tables actually gives us some solutions. First, let's see actually who uses graph tables, because it's new in SQL Server, but it's not really new technology. It has been out there for some time. So the first one I can think of is the suggestion engines. The best example I can give for this one is the Amazon. You go to the product page, you have all the information about the product page, but Amazon doesn't stop there. In the bottom of the page, it tells you, oh, you know what, I have other products like this one, and it lists them. Or it can even show you people are buying this one with this item, right? To be able to actually do that in relational database tables, we are going to need a lot of joins dynamically, and it's not going to be easy. Yeah, I know that. I know that. Yeah. So to be able to do this with relational database tables, that's not an easy join, and it's not going to be easy to actually display that page in 2-3 seconds in a product page. Probably what you are going to do is you are going to create all kind of SSIS packages, which is going to go maybe every hour and try to figure out this data, and you can read from just one table rather than try to actually do this dynamically. Graph database tables can actually do that for us. Second one is the government. Well, government likes to track us, right? So they have all those agencies, and probably you have records in each agencies. And whenever a government goes, they require some kind of like an MDM database, which they might write your social security number, and they will see only one person, rather than having all those data coming up And for example, if they're going to write my social security number, they're going to see only one Hasan Savran. They're not going to see 20 Hasan Savran coming up from each agency. Graph database tables is that. The last one, graph database tables, yes. Some of the systems, they are using it, yes. Yeah, some of them are using it. The next one is the social media. And the best one for that is the Facebook. What do you do in Facebook? Mostly when you go in it, you like things, right? So you are the user, and you like page, you like post, you like picture, you like whatever. So if you really think about it, the relation is always same. It's the like. The entity is the one which is changing. So if you can change the entity, the relation dynamically, you will actually save a lot of joins rather than doing this in relational database tables. Because if you really think about it, in relational databases, we have primary key, we have foreign key. That's it. There's no more information. In graph databases, you can actually have more. So to be able to actually give something different in graph databases, we have two types of tables in graph database tables. First one is the node tables. That one actually contains the entities. For example, users, products. Those are the entities. And each node table has a column named node ID. If you look at actually node ID with the select all from whatever the node table is, it's a JSON object. You really don't have that much business with it because you cannot change it. System uses that to find the data in the backend. All Microsoft actually suggests is it's suggested to put some index on it, because even if you are not going to use it, system is going to use it to find the data. And they can have any type of column, so they are really like any table. You can put any kind of data type in it. The second type of table is the edge tables. That one actually contains the relations. So relations are actually the first-class citizens in graph database tables. Just like the node tables, we have the edge ID. That is the identity of the relation. And it just works like the node ID. Every time you insert a row, that gets populated automatically in the back end, and Microsoft suggests that you should put index on that. And also, we have two more virtual columns in edge tables. Those are the from ID and to ID. That one actually creates the relations between entities. So, for example, let's say we have two users, our username Anna and Alec. We want to create a relation between them, and we want to say that Alec likes Anna. To be able to do that, we are going to get the Alec's node ID and put in the from ID here. And we are going to get Anna's node ID and put in the to ID here in like table. That is going to create a relation between Alec and Anna. You cannot update that relation. If you want to change it, you have to drop it and insert it back. Also, the directions are important. What I mean with this is Alec likes Anna, but that does not mean that Anna likes Alec back. If you want to create that relation, you have to create another insert. You have to insert a new row. Just like node tables, they can have any column. What does that really mean is you can actually more attributes about that relation. You can put out there like when actually that happened or any other information about that relation. You can put that in the edge tables. As I said, relations cannot be updated, so you have to drop it and insert it back if you need to change it. In here on the top, for example, let's say we have a store, electronics store, and we have products, right? What we want to do is we have a Kindle Fire here. In the back end, we said, we have iPad and Samsung Galaxy. So we can actually create a relation table named alike, and those are going to be our product table. And in the back end, we can actually make those relations. And whenever our user goes to our web page of Kindle Fire, with one query, you are going to be able to find all the products like this table or like this entity with one query. To be able to do that, you have to use the match clause. Match clause is only for graph database tables, and you have to use that in the value. You just need to pass the pattern. To be able to actually make it work, you use two entities and one relation. which is going to be, for example, from user, you are going to another user table by using a relation. And as I said before, the directions are important. And to be able to show the directions, you are going to use an arrow character. Here's an example. So in here, we have products table, wish table, and users table. As you might guess, products and users table are entity tables, and we have a wish table as a relation table. So our match here actually is going from the users table. It's going to the products table by using the wished relation, and I want to care only user ID 1. This is going to give me the user ID 1's wish list. Any questions about that? Now, let's have some demo. So in here, first I'm going to create some tables. So as you can see, I have the users table here. Can you see it? My users table, just to make it graph database tables, I am just adding this as node at the end. By just doing that, it makes it a node table.
Can you turn the lights off here?
Sure. Better? Okay, thank you. So the second table I'm creating is just a products table. As you can see, everything else is really same in the syntax. And I'm just passing as node at the end, and it makes it entity table. Then I'm creating some relations table. And for that, I'm just adding as edge at the end. But you can see I can actually add any kind of data type here too. So if you want to track any other information with that relation whenever it happened, you can actually track it here. So in here, I'm just tracking whenever I create this relation. So I have a like product relation table. I have a wished relation table. So I'm just going to run this and create it. The second, I'm going to insert some data. So really inserting is exactly the same it is. I'm using the insert comment, products table. I'm just passing some data. Same with the users. So let's do this first. Now let's try to actually see how this looks like. I'm just going to use the select statement just like regular table. As you can see, my node ID, actually there's a JSON object. We really don't care about it. System is going to use it in the back end, but it's good to know. So I'm going to actually insert some relations now in my relation tables. So as I said before, you need the from ID and to ID, which are the node ID from other entities. So I'm getting the node ID with product ID 1 and product ID 2. And in here, I'm just passing the get date because that's the date that created date. So I'm just passing that. So this is going to create a like relation between some entities, between products. But that is really not a limit here. So it doesn't have to be the same entity. This relation table does not care. It can be any entities, any graph table entities. So I'm doing the same here. I'm just adding some wish list here between the users and product. So I'm going to run this. It's going to insert them. So before I go to the third one, let's talk about this. Is actually available in 2017. So now 2019 coming up, and we have some kind of updates for graph database tables. They are not really minor. But as you can see here, we have no limit between entities. So really, you can say that product likes this user too, which is not going to make sense. In 2019, actually, there's a constraint. You can say that product will never like users. In 2017, it's not there. So you can have some constraint out there. And also, I think in 2019, it's the merge supports graph database tables. So you can use the merge statement. So now, let's actually go and try to find some data. The first one here, I'm using my tables. Yeah.
Are there some things that Microsoft Graph Database will not do that other graph databases
Not that I know. I'm sure there are some limits, but I don't have that much information about other graph database tables, so I'm not sure. Yeah, because this is the first version, I will be surprised if it can do everything. Let's say like that. So the first one here, I'm using my tables. I'm using the product ID 1, and I'm finding all the products like product ID 1. So if I run this one, it looks like I have Kindle Fire 7. This is the price, and looks like I have another Kindle Fire HD8 as a like between them. So it's really that easy for your website to go and find relations and display them, just like the Amazon page in products page, really. But this is a simple one, so this can get really complex. It doesn't have to be just two entities and one relation. This can really get complex. So in here, what I'm really doing here is I am using all my tables, and I'm finding all the wish list of these users. Then, actually, I'm finding all the products which are like this product. So it's going to give me all the wish list and the other products which are like that product. If I run this, well, I linked that, so I just care about the user ID 1 here. So it looks like Anna has 2 products in her wish list, Fire HD8 and iPad 3. Well, it looks like actually I have Fire 7 and iPad 2 in my store in the same time. So graph database tables can be really useful, and especially for developers, like creating like a product page of Amazon, it's pretty powerful. Next is the intelligent query processing. Well, this part of the SQL Server is probably the most complex part of the SQL Server, and mostly DBAs actually cares about this part. So until 2017, this part was working fine, but whenever actually it makes mistake, even it knows that there was a mistake, it was still continue doing the mistake again and again. So in that cases, we needed the DBAs actually go back and fix that problem maybe. In 2017, Microsoft actually started to make this process a little bit more smarter. Before I continue, let's actually see what really happens, because I asked this question in all of my interviews to the people. I say, okay, you had the select statement, you click execute. What happens? Like, okay, you see the results, but do you know actually what happened from between those two items? So you click the execute, and you see the results. What the actual SQL Server does. First, let's say we had to select all from users where ID 1, whatever, some kind of simple statement. The first thing SQL Server is going to do is actually it's going to parse your T-SQL and be sure that there's no mistakes in it. From that point, it's going to go find all the columns, tables, functions, and bind them. Be sure that everything actually in the database. If everything passes, believe it or not, it does some kind of algebra out there and try to do all kind of calculations, which I'm not going to go into that. But from that point, it's going to go to the query optimization, which is I'm going to talk next here. So in this point, SQL Server knows all the items you are trying to reach. It's going to go find the statistics. It's going to go find the indexes. It's going to check all the table sizes. And it's going to create all kind of execution plans. Not one, but as much as it can. From that point, it's going to go back and try to find which one is the cheapest or which for the system to run. When it finds that, it's going to pick that, and it's going to cache it, and continue, and execute the plan. When you try to run it next time, it's going to know that that is cached, so it's not going to go in this area again, which is going to be much faster. But that's the problem. Like sometimes, because of the estimates and the statistics, it might pick the wrong plan. If it picks the wrong plan, as I said before, it's going to actually cache that one, and it's going to continue running the wrong one until somebody actually goes back and fixes it. No, because what happens is actually it hashes the select statement for you. If that hash is going to be equal to the next time that you run the select statement, it will pick the same plan.
Even if another user would come in on a completely different connection.
That's correct. If it's the same statement, it will use the same one. if there will be a lot of memory pressure, it might get rid of it. If you drop an index, for example, that's using, it might drop it. If the statistic changes, it might drop it, but really they don't happen that much. Mostly you have to kind of go to DBA and they might just clear the cache. So, but in 2017, there are some good news coming up. So. And you might have this situation when you upgrade your SQL Server, because that's going to start from scratch. So the first one I'm going to actually cover here, the 2017 offers, is interleaved execution for multi-statement table value functions. Yes, I know. It's not easy to kind of read it, and I don't know why they picked that name, but I kind of give them credit too, because it's not easy to give a name to a product and feature. I tried it, and that's not easy. So anyway, what's actually happening here is multi-statement table value functions are, well, DBAs are not a fan of them. And there's a reason for it. And developers like it because you can encapsulate the programming. The problem is, if you have 2014 and 2016 version of SQL Server and you are using multi-statement table value functions, SQL Server will not care about the estimate. All it will say is, okay, I find a multi-statement table value function and your estimate is 100 rows. So in here, our developer is using the multi-statement table value function and his function is actually returning 200,000 rows. Guess what? SQL Server doesn't care. It says 100 rows. What happens is, it's going to get a memory for 100 rows and you are actually returning 200,000 rows and all the data actually spills to the disk. So rather than actually reading everything from memory, now we have to go to disk and get all that data. That's one of the main reasons that DBAs do not like this. If you have earlier versions than 2014, actually that estimate is 1 row. In 2017, they tried to make this a little bit smart. So whenever actually query processor finds this function in your execution plan, what actually it does is it goes and actually runs the function first, and it knows exactly how many rows that's going to create, and take that number as estimate. So the estimate and actual is always matching perfectly, so everything works much smoother. Second one is the memory grant feedback. Well, this usually happens is because of estimate problems, right? So SQL Server might think that, this query is going to return, 1,000 rows, but in here it just returns 1. So now it thinks that for 1,000 rows it gives this much memory, but your data is actually in it very alone. And the problem is, if you are going to try to run this query concurrently many times, you're going to get out of memory. So you have some problem here. Or the estimate might be too low, right? In here our data is actually spilling to disk again because SQL Server thought that 100 rows is enough, but your actual return 100,000 rows. So in this case, you're going to go to the files, and everything's going to get much slower. On top of that, if you're going to try to run this concurrently, the problem is going to be even bigger. So in 2017, it kind of helps with the situation. It's not really like a fix. I think it's just like a band-aid. But what happens is, if this happens rarely, it will make the same mistake first. But the second time, it will sense that it gives too much memory or too less memory, and it will fix it itself, even it's cached. It will try this, I don't know the exact number, somewhere between 10 or 15 times. If it's happened like frequently, it will stop trying it because it looks like there's a bigger problem out there, then it won't change it anymore. And that's available in 2017 Enterprise Edition. This one was in all editions. The last one, 2017 actual offers, is the batch mode adaptive joins. So there are 3 types of joins in SQL Server, in execution plans. I'm not talking about the left join, inner join. Those are actually depending how many rows are coming to the join. If the numbers is small, SQL Server picks the nested loop because it's much faster. We have two more. I think this is the merge, and I think the other one is it? Let me see. I'll forget the third one. But in here, what's really happening here is whenever we are getting number of rows coming up from our joins, it creates a threshold. Microsoft doesn't care how it creates a threshold, so I'm not really sure. But if the number of rows coming to the join is less than the threshold, it keeps the nested loop join type. If it doesn't, then it changes it. So it's a little bit smarter whenever it picks the join type, so things will kind of go smoother. And this picture actually represents you need the right tool for the right job. So. Now, let's have some demo. I'm going to cover only the first one here, because usually second and third one is mostly for DBAs. They like to see that. But for example here, I have a multi-statement table value function, and I am going to run this first in older version of SQL Server. So when I run this, so we have 62,000 rows coming up from this function. So what I said was right. Then probably I'm going to get an estimate 100 rows here. So if you look at the execution plan here, and if you look at the table scan, you can see here the estimate number is 100. But actually, actual number here is 231,000. So in this case, what's going to happen is it's going to register small amount of memory, and everything is not going to go in memory. Then it's going to start to write files. So now, actually, I'm going to go and run this in 2017. I'm not going to change anything else. The same query. It's going to be much faster this time. 1 second. If you look at the execution plan now, the number should match. The estimate number here is matching our actual number. So in this case, it registers the right amount of memory, and it picks the right join type, and everything works much smoother. All right. Next is machine learning. Anybody's interested in machine learning here? You guys know R? Okay. Well, 2016 actually machine learning introduced, and the name was R services. Still, I guess R services now. And it was available only in the Windows version of SQL Server. 2017 came up, and SQL Server, the Microsoft actually introduced a Python on top of that. So in 2017 you can run R script and Python. And it was still available only in Windows version. Now we have some information about 2019. So we know that actually in 2019 Microsoft is introducing Java. You can run Java in SQL Server. It's running in Windows and Linux, and the name is still same, machine learning. And I'm sure you're going to be curious about the faces here. Those are our DBA faces. They don't like it, and they don't want to turn it on, which they have their own kind of, good reasons. So what happened to me is I went to my DBA, and 2016 we are using, and I say, you know what, I want to actually try this R services. And my DBA was like, oh, it's not gonna fly. He's like, why? What happened? It's there. We pay for it. So it's like, well, there's no way for me to monitor this service. So yeah, you're gonna run some, script. You're gonna pass it. It's gonna work in the same machine of SQL Server. But there's no actual tools out there that I can monitor what is really happening in the back end. And this might actually, affect the SQL Server. It's like good reason. I back up from that, or I back up. In the meantime, now I think DBS doesn't feel that comfortable about this situation, because now they are saying, well, I need to learn all of those stuff to actually debug this, right? And somebody needs to, look at that. So I kind of investigate that a little bit. So that's what I found. In 2016, our services, and 2017, you can go actually those websites. Those are in GitHub of Microsoft Hydro Team, and those are custom reports. You can actually attach them to your SSMS, and they give you some kind of information what's actually happening in the back. They are really simple, but at least you can see who is using what and what packages are installed in the servers, and you can see some of the execution statistics. Unfortunately, third-party tools are not ready for this yet, and the newer, some beta versions of SQL Sentry has some information. So probably whenever they start to kind of improve their monitoring product, probably DBAs are going to be more comfortable with this. But until then, unfortunately, there's not that much monitoring for these services. So that's one of the main reasons you might get no from your DBA if you want to use it. But you should be able to at least use this in dev or QA or other environments, not in the product. So now, let's try to actually run this. So what I'm going to do here is I'm going to run our script here. Before you run that, you have to kind of configure the SQL Server, and you want to be sure that actually everything is working fine. You have to install this from the setup first, the machine learning package. And after you are done, you kind of need to run this syntax here to be sure that it's configured fine. So if I run this one, for example, looks like run value is 1, so everything is working fine. So what is really happening here is there's a service out there in the Windows services, you can see it, named Launchpad. Launchpad is actually responsible to contact the machine learning services. It moves the data and returns the data back. So that kind of checks that if that service is running or not. So to run any machine learning script, R, Python, or Java, you need to use the store procedure. You have to execute. And you have to pass the language. You just need to specify which one you are trying. The second one is the script. That's my R script out there. It's very simple, really. And you need to pass data. So here's the data I want to pass. For example, let's run this one first. This is coming from the SQL Server. So I'm passing a bunch of names and orders. My R script is very simple. All it's going to do is it's just going to sum it up and return back to me. And it's going to return back, I'm saying I want it in integer here. So when it comes back, it can be structured as much as I want. So let's run this one first. It's really simple. And that's my total. So that total actually got calculated by R in SQL Server. So the good part about this machine learning services is right now the Microsoft actually puts the machine learning very close to the data, which is great. Because if you actually play with the R server or any other stuff, like whenever you want to get pull data from SQL Server, all the connection strings and everything is right in front of you. And it's not really that secure. And on top of that, you are putting the whole network in the middle. So in here, you are putting all the service right in the SQL Server box. It's more secure and it's much faster. That's why I like it.
How is the security of the graphing database related?
Graph database of SQL Server? What do you mean by that?
So you showed us graph database versus
Relational?
relational. Is one more secure than the other?
No, it's the same security. Graph database tables just work in regular tables, and you can use them in SSAS, SSRS, whatever you like. So, but this is in the same package. And actually, I can show you here what they look like. Here I have some graphs here. When you look at under tables, you will see graph tables. So they look like almost the same, really. Next one is JSON. Well, in 2016, introduced the JSON type to SQL Server. Before that, you could actually say the JSON out there, but there was no way to actually, I guess, query it. In 2016, SQL Server introduced the JSON function. You have to use, well, Microsoft suggests that you should use the varchar next as data type because you don't know how big a JSON function or JSON object is going to be. But that's one of the main reasons that DBAs do not like this. Because when you are saying varchar max, really it's not going to be easy for SQL Server to estimate this. Because, well, you might have up to 2 gig. That's the limit of the varchar max. So if you are sure that your JSON object is smaller, please don't use the max. Use 1,000 or use 2,000. You can use that, and SQL Server won't give you a problem with that. So you don't need to use the max for that. So there are some functions that you can use. For example, is JSON. You are just actually passing here the JSON column. It will tell you if this is a JSON or not. This is great for constraints. Since everything is varchar something, you can actually put a constraint on that column, and SQL Server will actually check it before it enters the data if what you are passing is a JSON or not. JSON value will go and find the value that you are looking for in that JSON object. JSON query will return you another JSON. It can be an array of JSON, or it can be an object from the JSON object. JSON modify will modify the JSON object. We have OpenJSON, which will actually return your data as a table. And ForJSON will return your data in JSON format. So you can actually pick all the data in the tables, and you can return it as a JSON. Let's have some demo for those. Does anybody using them right now? Okay. So JSON query here. The first thing I'm going to do here is, so I have this table from Microsoft. First, let's look at it. Just a JSON object here, so it's not going to be clear, but it's a JSON object, and it has some arrays in it. The first I'm going to demo here is I'm going to pick the is JSON. So all it's going to say is true or false if this is a JSON object, valid JSON object or not. So if I run that, it should return 1. The second, I'm going to actually pick value from this object I just showed you. And it's going to get the delivered when note for JSON. It comes up as a date. Next one is the JSON query. So as I said before, there are some actual array in this, and you have to use the JSON query to get that object first. So in here, if I run that, it's going to get the events array, and that is the events array from that object. Next one is JSON modify. So we have a receive by in this row. I'm going to change it to same Nasser. So if I run this, it's going to return the that makes it same Nasser. In here, I'm going to use the same one, and actually I'm going to update the table this time. So if I do that, one row is affected, and if I go and look for it now, the one that I just update, received by, it was okay for Zoro. So let's make the same master. It's going to update only that row. Now if I go here, same as well. The next one I'm going to demo here is the OpenJSON. What I'm really doing here is I'm going to actually, rather than returning as JSON, I want to actually make this table. And I'm going to return only one column here, return delivery data. Let's see, the delivered on, and I know it's a date time. So if I return this one, it's going to be a event name and the date time. Also, what else I can do is I can add the for JSON auto and without array wrapper, and that will actually return the data in JSON format. So you can do a lot in SQL Server without going to your IIS or anything like that. You can do all those JSON functions in SQL Server, which is great. Unfortunately. all you can really do is you can just use it as text, but it's still gonna be kind of going like that. Because I think if you click on it, it's gonna try to open it as XML. It's still not good. You can copy it and put in Visual Studio. It should be fine then. Maybe VS Code might be able to do that. I don't know. And so this is only the JSON. What else it can do? Actually, it can, with some functions, you can actually return this if you are doing the geospatial data. You can actually create GeoJSON object right in the server. So you can actually take this and pass it your map, and it will actually, you know what? Let me show you that. Yeah. Let's try. Yeah, it's okay. It's fine now. Worries. I mean, okay. So you know what? I have a hot. I can do this. It's okay, I can turn this on and it will work. Always think it up. Okay. So I have a page here. Usually I demo this in my geospatial data talk. But what you can really do here is, let me see. So Google Maps or Bing Maps, both of them actually take the GeoMap as, if you can just drag and drop it and it will show it to you. So what you can really do here is you can actually put those in your SQL Server and let them return by GeoJSON by using JSON functions. So what's going to happen is when user comes here and click Ohio, this is going to call the IIS. It's going to call and pass the Ohio to SQL Server. It's going to create the Ohio map and it's going to return it. So when you click on it, that's going to be that easy. Google Maps know what GeoJSON is already. SQL Server is the one which is creating it. So IIS is really doing nothing, just passing the values out there. So you can do that by the SQL Server now, so which is great. All right. Next one I'm going to cover is the memory optimized tables. They are pretty strong and they can do a lot. There are two types of memory optimized tables. The first one is the durable tables, which is your data actually stays in memory and the file at the same time. So whenever you actually try to select the data, it comes from the memory, so it's much faster. And whenever you insert an update, it insert and update the actual memory table and the file. So if something happens to the SQL Server, you won't lose the data. When the SQL Server comes back, your data will get retrieved from the file to the memory. So you want to be sure that you have enough memory. It's much faster than file tables because you're actually dealing with the memory here, but it still needs the I/O because you still need to insert an update. You still need to deal with the disk. Non-durable tables are different. So your data actually is getting stored in memory only. So if something happens to SQL Server, you will lose that data. There's no way to back it up. But it's much faster than durable because you don't need I/O at all in this moment. This is great for caching data. And I like actually this one more than that because I can actually use a SQL Server for caching. So if you use the Redis or something like that, guess what? I don't need all that extra DLLs or other kind of knowledge. I know how to use select statements. I can actually use a SQL Server for that. I mean, you can write scripts if you like, but usually I make my web application to kind of do that rather than SQL Server. So before I continue, let's look at that. Because the price actually between the disk and the memory is getting really, I mean, look at the number here. In 1980, 1 terabyte hard drive was almost $400 million. So you see this price cuts usually when a new media is getting actually introduced. Look at the compact disc came up and look at the cut here. DVD is the same way. And we have the 4K TVs, it's almost like half price. So I don't know if there's any new media is coming up or not, but when it happens, the price actually cutting a lot and they're getting very close to each other. So price-wise, actually, memory makes sense. But if you look at these numbers here, that's the one that actually shows you how powerful it is actually to try to pull this or push the data to your memory rather than this. So in hard drive, it can write or read the data 100 megabytes per second, right? And it can find the data in 5 milliseconds. So right now, most of us really using this one here. So it can read half gig per second, which is pretty fast. And it can find what you are looking for in 50,000 nanoseconds. Pretty fast. But you still cannot compare to memory here. The memory is like it can read 100 gig per second. It can process that much. And it can find what you are looking for in 50 nanoseconds. I'm not saying you can process the 100 gig because probably your CPU cannot do it anyway. But I mean, this is your potential. So, sure, but I don't know if it can compete with this one. So it's really, in future I can see that memory tables are going to get more popular because of that, more popular. So also before the demo, let me actually introduce you another store procedures just for memory optimized tables. And those are natively compiled store procedures. Those are working only for memory optimized tables. Those are actually the store procedures that you create. But what actually SQL Server does is it creates a DLL from the store procedure and put it in the memory. So your data is in memory, your function is in memory, you get the request from user calling that store procedure. In this moment, SQL Server has to do absolutely nothing because, well, store procedure is already compiled in the memory. Your data is in the memory, so everything goes very fast like this. The only limitations you are going to have is those store procedures cannot actually have all the syntaxes because in-memory tables has limitations. So it cannot have all those syntaxes like, for example, case, if statements, and other stuff. It doesn't support those. So, but it's fast. And DLL, all the DLLs it creates, it stay in the memory, but physically they stay in this folder here. So if something happens to the SQL Server, whenever it comes back, it gets them from here and puts them back in the memory.
Are storage procedures always done with SQL?
Yeah. So now let's talk about the 2017, SQL Server 2017. Those are actually what is new in memory tables in 2017. They support the JSON. You can actually use the cross-apply and top and with ties syntaxes. You can create computed columns on them. There is no more index limit on them. You can use the case support, and you can run those two store procedures for them. So when you look at that, it's like, okay, whatever. But if you try to actually combine them together, it becomes really, really powerful solution. For example, if you actually combine the JSON support, computed columns, and no index limit, this one almost gives you a Redis solution, a NoSQL server, really. Because your data is in the memory, you can actually write JSON queries on it, and you can create computed columns, which you can use them to make indexes. So if you think about the Redis, what do you have in the Redis? We have key and value. You must know key to actually get the value. If you don't know the key, you are stuck. But in here, you can create the same structure. You can have a key, which will be your primary key. Value will be your JSON object. But guess what? Now you have the JSON support, so actually you can go and query that value. You cannot do that in Redis. Now, let's actually create it. So what I'm doing here is I am just creating a table here named summaries. It's pretty simple. Usually in Redis, that's what you have, ID and summary. That is key and value. But I'm not actually stopping there. What I'm doing here is I'm creating a computed column named driver ID. I know that JSON object is going to have the driver ID in it. And I'm just getting that, casting it as integer, and putting it in that table. Then I put an index on it. So things will get much faster rather than table scan. Actually, this time we are going to go to index scan in this situation. So let's actually create this one first. Now, is JSON the one that actually I just introduced you? I'm going to create a constraint. Since this is a varchar max, this can be any kind of characters in this. So I want to be sure that whatever goes out there is a JSON object. So by doing that, I'm just adding a constraint on it, and I want to be sure that if it's not JSON, I don't want this. So now I'm going to insert some JSON documents in this. Let's see how many. 70,500 JSON objects in it. So if I go by the primary key, this is going to be pretty fast because that's our primary key and it's indexed already. So if I run this and look at the query execution plan here, it's pretty fast. And if you look at the execution plan, it's an index seek, which is good. But as I said before, we might not need that. For example, in here, what I'm doing here is I'm actually going the JSON object and looking for driver ID 2. So rather than, I don't know the key, but I want all the documents which has this actually condition true. If I do that, it's 1 second, and what actually it did is it went almost 71,000 documents and find the driver ID 2 and return it in 1 second. If you look at the execution plan though, that doesn't look that good because it's a table scan. That means actually it tried in every row. So, but we have an index on it, right? Now, the problem is our index is integer, not a varchar. And in here, we are actually passing a varchar. That's why it couldn't find that index. This usually happens with the ORMs. So, if I actually pass 2 here, it didn't even take 1 second. If you look at the execution plan, now actually it goes to index seek. So we are in memory table, and we are hitting an index, and we are going in JSON objects and looking for the data. Also, so right now we look at the JSON value here, but we can really do this one here because that's computed column. We don't need to write this JSON function every time. If you do that, you should be able to hit the same index because that's the same signature here. Driver ID is actually this. So SQL Server is actually smart enough to pick that index. So that's all I have for in-memory tables. Any questions? Next one is temporal tables. Temporal tables, when somebody says it, the first thing comes up in my mind is the history, because they are out there actually for keep your older data. What actually it does here is this is your real-time data. Whenever you make this table, temporal table, SQL Server actually takes the same table, same schema, and creates another table. And whenever you are creating it, you have to pass 2 date times, 2 actually. Those are the start date and end date. By using that, actually SQL Server is gonna able to find the data in specific date or specific time or specific date range. And this is great if you need to create like any calculating trends, finding your data, what it looked like last month, last year, and you truncate it, I guess you can recover it, because sometimes I do it in production, right? Yeah. Well, yeah. But it happens. So temporal tables are good for that. And in 2017, though, there's a challenge, because if your table is a busy table, if you have too much updates, deletes, and insert going on, well, your history table is going to get pretty large. And unfortunately, in 2017, developers or the DBAs are the one who's responsible to purge that data. So if you don't care, for example, after 2-3 years, you need to kind of figure it out how you are going to delete that data from the history table. SQL Server is not going to do that for you. And there are some options. You can push on the Azure cloud, or you can just delete it, but it's going to be your responsibility in 2017. I mean 2016, sorry. In 2017, actually it can do that for you. In 2017, there's a retention period. This is how you actually define it. So that's my regular table. All it's going to need from you is start date and end date. They must be datetime too. And this is going to be for actually starting date. That's what you are defining here. End date is going to be for the end date. And you are making a system timetable, which is a temporal table, and it's going to use these two columns. You can name them whatever you like. And I'm just saying system versioning on. You can, this is an optional. If you want to actually name your history table, you can do it. If not, it will just give a custom name. And this is for the 2017. It will start to purge your data after 2 years automatically, so you don't need to worry about the script. So temporal tables doesn't do it in 2016. Sure. Yeah, I see them, some of the hospitals actually using them too, to give them trend of lab results. They are kind of good for that too. Only challenges I see with temporal tables, if you have computed columns on them, things can get a little bit kind of tricky. And if you need to kind of truncate it, for example, sometimes I use them in lookup tables, which they are great, so you can actually see what has been changing in the lookup tables. But if you have like SSIS package, you want to kind of get it from the production and repopulate it, so you cannot truncate them without kind of turning them off here. So that might get kind of challenging sometimes. Now let's see if some demo for this one. So in here, all I'm doing here is really I'm just creating a regular table. I'm adding start date and end date. Those are the dates, start dates, and the end date. I'm passing, this is the same script you just see. This is just going to create a temporal table. But its power actually coming out from its syntaxes. So, for example, this will find how my data was in this specific date. What it actually is going to do is it's going to actually join the history table with your real-time table, and it's going to give you the data that you are looking for. In here, I'm just using the as of, so it's going to show me how my data was in this date. You can use the contain in, and this is the actually valid from and valid to. Those are the two dates that we started, which is a start date and end date. And I'm finding all the data in contain in those dates here. If you run that, it will show you all the data you had in those times. You can use the between, it works. Yeah, everything. It will include everything. Yeah. And this will work in this kind of similar way. It shows the between date. Really the difference between those are just like equal or equal and larger, and that's the only difference really. And you can use the from and to. It works the same way. It will find all the data for you. You can do that if you want manually. You can join those two tables and you can kind of run all kind of queries if you like. But those are the ones actually coming up with the temporal tables. So you don't need to write those queries. This will show you all the data you have for this person in history and real time. So they are useful for sure. Next one is computed Columnstore indexes. Anybody using them? They are for 2016. Now they came up in the 2016 mostly. And what actually happens is whenever you make an index, usually it's a row store. So SQL Server actually indexes by row. In Columnstore, actually it does it by column. And it's mostly for analyzing the data. It's not for the OLTP or websites really. And it makes things much faster and smaller. Whenever actually you use a CCI, it will compress your data almost like 10 times. And Microsoft claims, which I will sometimes see the performance, it will work 10 times faster to analyze your data. And that's mostly for aggregation. So in 2017, actually it started to support LOB columns, which are the varchar max columns, which means we can do some interesting things here, because JSON is the varchar max. So in here, you can actually see in the left side, we are using the same table. One of them is going to have the regular non-clustered index, and right one has the clustered Columnstore index. When you run this, this index is going to actually run in the whole table. It's going to compress the whole table, and we are going to see some results here. So I'm inserting the same data in the tables. The first one, I'm adding 3.5 million rows. And well, for this table, at the end, it takes 2.5 gig for this data to be in the SQL Server. The same data, 3.5 million, 254 megabytes. Well, that's a huge difference out there. On top of that, what I'm going to do here is I'm going to run all kind of crazy queries on this, right? So this is the query I want to run. It really doesn't make sense, but the point is, it's using all kind of JSON functions. It's using aggregation. It's using average. It's casting stuff. It's using group by. It's kind of crazy, right? So I'm going to run this in both tables for 3.5 million JSON objects. If I do that, the left side does it in 39 seconds. This one does it in 11 seconds. It's pretty fast. This is great whenever you are analyzing the data and reports, but it's not that good for your web application, because web application is going to look for the row store that you need, usually that ID. You don't want the aggregation, mostly in the web applications. It's really useful. I know last time here I talked about the CosmosDB. I kind of give this one for CosmosDB kind of competition in SQL Server. So you can actually use the same kind of idea here, because you are actually querying by JSON, and you are putting everything very small here. So you can kind of create the same kind of environment like CosmosDB in SQL Server by using CCI and LOB columns. That's correct. I mean, it can compress this much because usually, for example, let's say your column name is gender, right? What's going to be in gender? How many different values is going to be in it? So it can compress it really fast. So, and it makes it smaller. That means your I/O is going to be less, and things going to go much faster. Next one, which not many people actually talks about it, is the reporting services. In 2017, actually has a REST API for reporting services. And this is great, especially for web applications, because I don't know about you, but whenever I write, they create all those reports and they want to put the same security on it, right? Now in web application, you usually use another role system, right? So you can actually, you don't use the Windows group roles and other stuff. So you have this custom role tables, user tables, web applications using, but they want to actually apply that to the report in the same time, which might be pain, and usually IT doesn't like that because you have to kind of manage that. So in here, what you can do here is actually you can go hit that REST API, get that report, and actually render in your web application. In that case, security will be exactly the same because you are in the web application. So you can try that. Not many people are talking about it. And also, if you are using Power BI, those REST APIs, you can actually use them as source. So Power BI can pull data from here, from the reports.
Have you ever come across anything that moves into a PDF
Moves into PDF. What do you mean? From
from the report?
not really. Not really. It doesn't save as with PDF. I think so. I think so. And I think Power BI, I don't know if that's an option. You can actually display the reports in it right now, I think. So you can actually put that report file in Power BI and it can render. And I think Power BI can do that too. So the next one I'm going to actually show you is some of the new functions, which there are some good ones, which I am excited about the trim, because I've been looking for that for a long time. You have to do is L trim, R trim. Now actually guess what, you have trim. So this is great. Let's look at it. So I'm creating just a temp table just to use it here. And I put some kind of information in it, and let's do that. So that's my table. First I'm going to use a string ag. So what I'm going to actually do here is, let's run both of them together. So I'm putting a special character between each column. So that's my object. I'm picking the email here. If you want to actually send email to all users, you can just put a special character right between them by using the string ag, and that will make your life much easier. Also, you can actually, if you want, you can put special characters too. So to actually run this, I have to run this in. This is not going to really show it because I think that is enter. Text. So if you look at here, there's actually a breakline between them. So if you want to do this like in CSV or something, this will be very useful. Or you can even use the group by. So if you want to send emails and you want to group by gender, you can do it. You can concatenating values. So let's try this one. Now actually I'm adding a special character or any character between each columns here. Those are available in 2017. Trim does the same thing. If you don't pass anything, it's just going to trim left trim and R trim. I don't know why they waited that much for this one, but it can do more than that. So it can actually trim only the characters you define. So in here, it did everything but the that here. This one is great if you are using with the geospatial data. You can actually, because in the GeoJSON it uses parentheses, so you might need to kind of change them. Translate. In here it finds all the parentheses and changes to square brackets. Just like this. Same here. You can actually put special characters. So I put a special character right between good and morning. And those are the functions for 2017. Yeah, which one should be? Yeah, which one should be on? As much as we want, really.
Right, but
Yeah.
in your case, you did
So here, so I have 4 characters. One of them is white space. Yeah. So everything is gone, but just that add symbol. Yeah. So, all right, let's see.
What's the syntax on 160?
It's concave with white space. So what it just moves it. So here. It just adds that in between each columns. Yeah. So if I remember right, I think this is my last slide, but I think I forget to give you one demo, which I'm really excited about, because I was just working on that earlier. So when I was actually covering the JSON, right? So I said whenever you can select the data and you can return as JSON. So what does that really mean, right? That means, well, if you are in the front end, you create your form and you click submit, and that goes to MVC.net. And well, if it's in JSON format, actually it knows how to format it and create your object, right? So well, if we have the JSON, we should be able to do the same thing from SQL Server. In this way, we can actually get rid of the ORM, because that's what it does. It has a mapping, right? So what I'm going to do here is, first, let's look at our data. So I think it's in the sale tracker product table. That's the one I'm going to care right now. So let's look at our table. This is the table, and I'm going to create my object, the same names, just the ORM or entity framework. You just match the names. And let me go here. So that's my product. Everything is matching my column names. So I have a controller here, a product controller. All it does is user asks for a product ID, and I go in my repository, and my repository looks like, let's see, where's my repository here. It's just like a regular SQL client is using, and it's going to run the store procedure, which is great for SQL Server because it can cache it and it's using the store procedures, which is great. And really nothing special here. So there's no ORM here at all. So let's look at that store procedure too before we actually show how it's going to work. So if I go to the store procedure, this is my store procedure. It's just a select statement, but at the end it says for JSON auto. So it's going to actually create this in JSON object, and it's going to return that to the MVC.net. From that point, MVC.net should know and map this to your object without using any ORM. So let's try this. And divide it. Let's go okay, so product ID is 1. Go here, run the store procedure, look at our model. It's an object. So we got rid of the ORM, and SQL Server handled the JSON, and really you get rid of a lot of code up there in the middle. So, and your DBA will be happy. So usually they don't like the varchar max, but you should be able to return your data as JSON. That shouldn't hurt the SQL Server that much. And in the meantime, you get rid of the ORM this way. And also, which this has been, actually here's the data I'm displaying here. So if you got the news, I think it just happened last month. So Microsoft actually started to work on getting rid of the SQL data client from the .NET framework, and they have right now Microsoft Data SQL Client. So they are changing the namespace for this, and it's in preview right now. You can actually get it in Nougat. It's right here. This is preview, and This one actually, the difference here is it supports the 2019 features, which the current one does not support. For example, UTC 8. So 2019 supports that, and your tables might be much smaller if you use that data type. So if you want to use that SQL client, you have to get this NuGet from here. And this actually supports in .NET Core too in the same time, and .NET Framework. So, yeah. And why they changed it, I'm not sure, but they couldn't keep the same one. Yeah, they couldn't keep the same one. So what's going to actually happen here is if you want to run this, this works. If you are using the .NET Framework without the .NET Core, you must run this in 64-bit. Unfortunately, they are fixing that right now, and your IIS has to be in 64-bit too. So that's the reason I have here the 64-bit. Stop this. This has to be 64-bit, and also from the, I think the options you have to pick here. You have to use this on the 64-bit version. But this is only for the preview. I'm sure they're going to fix that. .NET Core, you don't need that. That's all I have today. I covered a lot. I hope you learned something new, and thank you for coming and listening. Thank you.
So are any of these things, specifically the 2017 and 2019 things, available in Azure SQL?
Azure SQL should always have the latest. I'm not sure how many of 2017 is there for sure, but I'm not sure 2019. Some of them should be, but yeah, it should be at least preview mode for sure. Yeah, yeah. So whatever I show today should be there, if not soon. Another question? Yes, you can. You can join any kind of tables to graph tables. Yep. No? Thank you.